Okay guys, we're going to do graphing exponential functions. So let's take a look. Okay guys, so here is the parent graph, or the parent function is that right there, y equals b to the x power. If that b value is between 0 and 1, we're going to call it exponential decay. The graph's going to kind of look like this, that it's going downhill. Okay, if it is bigger than 1, so if this term is bigger than 1, okay, it's going to be called an exponential growth, so that means it's going to be increasing, so it's going to look something like that. Let's go and look at some examples. Go ahead and pause this and copy this down. Alright, so here's the general form when we go to graphing. It's written here, but I didn't like how it looked, so this is what I think it looks a little bit better. This is y equals b to the x minus h power, that's an exponent, plus k. And this should look pretty familiar. The h is going to give us the horizontal shift, or left, right, and that is going to be the opposite. Okay, and then the vertical shift is going to be up or down. That's the k value, and that's just what it's always been. Okay, these steps are on the page, I believe, but when you're doing these, you're going to go ahead and just make your parent function table. Okay, we'll use the values -2, -1, 0, 1, 2. Yep, I have a lightsaber. I know it's pretty sweet. Then we'll plot the points. Then we're going to shift, and then we'll connect those new points. Let's take a look. Okay, so the first thing that we're going to do is do the parent function, which is just really going to be y equals 3 to the x. So we're just going to focus on this part right here. Okay, so we have our x and our y. Okay, so we're going to do is -2, -1, 0, 1, and 2. So this is going to be 3 to the -2 power, 3 to the -1 power, 3 to the 0 power, 3 to the first, 3 to the second. Okay, I'm going to do the positive ones first because 3 to the second is just 9. 3 to the first is 3. 3 to the 0 is 1. Anything to 0 power is 1. Now, I can either do 3 to the -1 in my calculator and get the decimal, or we just know negative exponents flip it, so it would be 1 over 3. And then 3 to the -2 would be 1 over 9. Okay, I'm going to go ahead and scribble that out because I don't need it anymore. Now we're going to go ahead and plot those points. So the first one is 2, 9, 1, 3, 0, 1, -1, a third, it's right there, and then -2, 1/9. I'm not going to grade you terribly stickler on exactly those points, but put them about where they should be. Then we're going to go ahead and graph this in. This is just our parent function, but I want to have you see the shape. Now look how I graph this. When we're doing exponentials, there's no way that this exponential y equals 3 to the x power will ever be negative. So if you notice, it gets really, really close to this line right here, or this x-axis, okay, but it never crosses it. Now let's go ahead and do our shifts. The -4 tells me we're going to go to the right 4, and then the +2 is up 2. Okay, so let's go ahead and shift those points. To the right 4, up 2. Okay, I shifted those points. Now I'm going to go ahead and draw in the graph. And if you notice that line, it's called an asymptote, that line that it never crosses. If you notice, it just shifted with my vertical shift. So I just kind of kept that same shape that I did on the blue one, and then with my shift, that's my new graph, is that red one. If you look, our b value was 3. That's bigger than 1, so it is. If you notice, our graph is going uphill, or what we like to call exponential growth. This would be a growth graph that is showing exponential growth. Okay, for this, let's go and make our parent graph. That is going to be how we make our table, that right there. And then I notice that -5 is on the back end of it. It's not with the exponent, so that's just going to tell me that I'm going to go down 5 when I shift it. Okay, so let's make our table first. So x and y, so I have -2, -1, 0, 1, 2. So this is going to be 1/2 to the -2 power, 1/2 to the -1 power, 1/2 to the 0, and 1/2 to the first, and then 1/2 to the second. Okay, so let's go ahead and, you can do these right in your calculator, but 1/2 to the negative power is going to, you flip it, so it ended up being 4. 1/2 to the negative 1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 power is just 1/2, or 0.5. And then 1/2 to the second power is 0.25, or 1/4. One of those two. Okay. All right. So let's go ahead and plot those points. Okay. So -2 is going to be 4. Okay. -1 to 2, 0, 1, then 1/2, and then 1/4. Okay. So we're going to go ahead and graph this in here. Same thing, it gets really close to the x-axis but never crosses. Now let's go ahead and shift this. So we're going to shift all these points down 5. Okay, I shift them down. Now I'm going to go ahead and draw in my new graph, and it's going to keep that same shape where it never actually crosses that line. Now, if we look at this, this b value was less than 1, okay, because 1/2 is less than 1. So if you notice, my graph is going downhill, or we like to call this a decay graph, okay? Okay, go ahead and start on the practice problems, and make sure you get them checked as you go through them. Good luck.